And we're going to switch over to Richard now, who's going to talk a little bit about what he's doing with Earth photography and why he feels that this is an important activity for students to be involved in.
Hello Rita, hello everybody. So let me talk for a minute about my plans in space. And first let me again thank everyone there at the headquarters of the Challenger Center, plus all the schools and students who are attending today. I'm here at the Gagarin Cosmonaut Training Center training again after a short break. In fact, today I just had a very exciting session. It was the first time we got to do what's considered a full simulation, where we went through the entire launch sequence inside the simulator. So for me and Nick, my backup, today was a particularly fun day. But one of the very first things that I thought of doing when I began to plan this flight was to take photographs of the Earth, intending to purposely replicate some of the Skylab photography that my father did. Skylab being one of the first ever human outposts in space. It was again one of the first times people got a chance to take a large selection of photographs of the surface of the Earth and begin this process that now is described as, Earth observations or crew Earth observations, where down through the years they've been observing how the Earth has changed. And since with my flight, as well as the Russian cosmonaut I'll be joining in space, Sergei Volkov. Sergei is the first second-generation Russian, and I'm the first second-generation American who will go into space. And so I thought it would be a particularly poignant point in history to look down at the Earth and try to take a photographic essay to see how the Earth has changed in this first generation of space travel. However, I think it was also a really brilliant idea on the part of the Challenger Center staff to think about looking forward 35 years, not just backwards 35 years, and see and project as to how the Earth, or what parts of the Earth might be most interesting to photograph. In addition to the things that Rita has mentioned, there's something I always like to mention. Most of the time when people talk about changes due to human impact on the surface of the Earth, they're almost always referring to negative impacts, or things like the growth of cities, or desertification, or the cutting down of forested areas. And by all means, I think the majority of human impact is not necessarily beneficial to the surface of the Earth in which we live. However, I think it would be interesting to also look for the opportunity to see how, especially in the next 35 years, we can either change the course of areas that we may have already been doing some harm to, like, for example, the Amazon River Basin, where people have been clear-cutting a lot of those forests. Or a more specific example might be that forestry activities have really improved in the last 35 years. When I was young, I remember people talking a lot about how much of the United States forested areas had been cut, or were either being cut or had been cleared. And as an adult, the thing I hear more about, or at least hear somewhat commonly, is I hear about how good forestry practices are now sustaining more of the forests in the United States. And again, I'm not personally familiar enough to know where the successes exist and where the challenges are these days. But I thought for you as students to look for negative human impact, potential positive human impact going forward in the next 35 years, and then also what I'll call just the natural changes in the surface of the Earth.
Hi, we're going to go to Richard Garriott now, who's coming to us live from Star City, and he's going to talk a little bit, continuing his discussion, about what kinds of things he might expect to see when he is in space in terms of Earth photography. And maybe, Richard, you can tell us a little bit about what camera you're going to use.
Yes, indeed I can. I can tell you, first of all, this this right here is the actual camera that I will be taking with me into space. This is a Nikon brand camera. It's the most recent model, which is called a D3. With the Nikon D3, the reason why I'm taking this particular camera, which is, like I said, the latest model, is it has a higher resolution chip than has previously been available. And this particular model takes what's called a 12 megapixel image.
It has
a very high resolution image compared to what has been flown before. And this will actually be the first time this particular model of camera has flown onto the International Space Station. So anytime you fly new hardware, it actually is, there's a process that has to be done. In this case, another copy of this camera has already been taken to the company Energia, which manages all the hardware that goes to space. And Energia is testing this camera with vibration and temperature and all kinds of other what I'll call stress tests to make sure that this camera will operate suitably on board the ISS. And presumably that'll come back fine, because the previous models of this camera have all passed that with no problem. The lens that you see here on this is the lens I use here on the ground. This actually is a variable zoom lens that goes pretty wide for shooting in indoor spaces such as the room that I'm in here now, and in the simulators and things that I use as part of my training. The lenses, however, that I'll use on orbit will differ, will vary. They have lenses like this that are fairly wide angle that I'll use from time to time. But when doing the Earth observation photography, I'll generally be using a considerably longer lens. And in fact, they have lenses, the nominal lens that I'll be using is 250 millimeters. That takes, compared to sitting here in the room, a very close-up shot. However, they also have a very long lens, a 400 millimeter. If I could, that's really the effective focal length. It's not the physical length of the lens, but that 400 millimeter lens, which can even be doubled to an 800 millimeter lens, will take pictures that are more and more what you might consider close-up of the surface of the Earth. The problem is that since the International Space Station is traveling at 17,210 miles per hour, if I take a longer and longer lens to take a more and more magnified photograph of the surface of the Earth, it's like taking a camera and shooting out of your car window at the Earth going by, or the land going by beside the car. If you just shoot out the side of your car and take a picture, the landscape you're looking at will be very blurry because of how fast it goes past. And the same problem comes up
beside the car.
Use a very,
if you just shoot out the side of your car
while taking Earth observation photography from the International Space Station. So I will generally be using again that 250 millimeter lens, which will have a fairly wide field of view, which means that, for example, I won't be seeing your house or my house or any small structures. I'll need to be taking photographs of very large structures, and so whole cities at a time, or whole forested areas at a time, coastlines, river deltas. Those very large-scale things are the things I'll be looking with.